Hi there everybody, today we're going to look at transformations of graphs. It's very, very popular these days, certainly with the new GCSE, kind of comes into the back end of an awful lot of kind of questions, and most students don't always particularly like it, so you might want to take notes as I go through this. So we're going to look at translations, so the idea of a graph moving, and we're going to look at stretches, and we're going to look at reflections and what rules are applied to those. Okay, so translations of graphs are often referred to as movement of a function, f of x. So that means you're going to take something and literally move it left and right. Okay, so let's have a look. So if you've got a graph of f of x, then if you literally take exactly what you've currently got and add a number to it, what that does, it just moves it up. Or if you consider it very, very carefully, if I said I've got a function here and it gives me a y value, then if you just add a number onto it, then your y value is literally going to go up. All right, so f of x plus a, we call a translation in the y direction of a vector 0a. All right, so basically it moves it up. All right, so if you're not quite sure about vector notation, the top number is left and right, and the bottom number is up and down. All right, so plus a will literally move it up. Okay, if it's inside the bracket, and again, this is the important part of this one, if it's inside the bracket, then it's not a case of moving it up or down anymore. We're talking about the x value actually changing. And because the x value is literally changing, then that's going to move my graph left or right. Okay, so it's a translation in the x direction by the vector, and this is the big bit, it's going to be minus b. Okay, so it's the opposite. So if you move your graph, if I add 2 to your x direction, what actually happens to your graph, it moves left 2. All right, so if I put x plus 2 into my normal equation, instead of the x, it'll move it left 2. And if I take my normal equation and replace x with x minus 2, so 2 left, then it would be right 2. So it's kind of the opposite. All right. So in terms of this one, let's have a quick look. So if I look very, very carefully here, so I've got a graph of y equals x squared, and I want you to describe the translation when I add 4 to it. Well, when I add 4 to it, this is outside of obviously the x squared. It's not changed the x in any shape or form, has it? I've just added 4 to it, so this is going to go up 4. All right, so translation by vector 0, 4. And underneath it, same kind of idea. It's got minus 4, so it's just going to go down 4. Okay, so they're relatively straightforward. So you've taken your x squared graph and it has not changed the x squared. It's just literally tagged some numbers onto it. However, this one obviously has changed. So if you've got a graph of y equals x squared, well, it's not just a case of x squared plus 2. This is now your x has changed and you've added 2 for it. So this is the rule that I'm applying. It's going to move left 2. All right, so minus 2, 0 in terms of using a vector. And then over here, again, the x value has changed to x minus 3. So that's going to move right 3. Okay, so right 3, so 3, 0. All right, so that's translations. Okay, hopefully made some decent notes on that as I've gone through it. Stretches. Well, stretch is the idea of it basically stretched in 2 directions. It can either go stretched in the y direction, that means pulled upwards, or it can be stretched in the x direction, and that means pulled left and right. Okay, so it means it's going to stretch it or make it thinner. That could be either way by a certain scale factor. So if you've got the number outside, okay, thinking about the idea of when I added something on the outside, it stretches in the y direction by that scale factor. All right, so if I had 3x squared something, it would basically the x squared graph and stretched in the y direction by a scale factor of 3. Okay. If your value is inside, and again, this is kind of similar to what happened when I changed the value of x, then it is in the x direction this time around, but like the other one, it's kind of the opposite. All right, so you're hopefully getting a pattern here that if it's to do with the x value and it's inside the bracket, then it's to do with the x direction, and it's kind of the opposite of what you would expect. All right, so it's not going to be stretched in the x direction by a scale factor of 3. It's going to be stretched in the x direction by a scale factor of 1/3. Okay, if I did it that way around. So let's have a look at some examples. So here you've got the 3 on the outside. So it's going to be a stretch in the y direction by a scale factor of 3. So you'd have to write that. This one is going to be a stretch in the y direction by a scale factor of 1/2. So you'd have to write that. And then over here, again, you can see now, this is now in the bracket. All right. And the reason this is obviously different is because I'm going to square the 2 as well. So that would be 4x squared if I actually multiplied it out, but we're not asked for that. We're literally just saying, right, the x has changed to 2x, so therefore it's a stretch in the x direction of a scale factor of 1/2. All right, so if you think about that, that means it's going to pull it in a little bit, which will be very similar to basically a scale factor of 4 in the y direction. Because if I expanded that out, that would be 4x squared. All right, so it will be very, very similar in the same kind of idea, but stretch the x squared at a scale factor of half. And then this one over here, well, this is going to be a stretch in the x direction by a scale factor of 8, okay? Because obviously it's an 8, it's always kind of the opposite of there. All right, so that is stretches, okay? So last one, reflections. Okay, so we've looked at the previous two, and this kind of follows the same kind of idea. Right, so this one is y equals minus fx. So the minus is on the outside, and this is a reflection in the x-axis. And the way I kind of look at it, if a reflection in the x-axis, it goes up and down, doesn't it? All right, so you think about reflection in the x-axis, you take a graph, it's just literally going to go up and down, all right? So it's still, from my perspective, it's kind of up or down idea. All right, so minus fx is described as a reflection in the x-axis, but it goes up and down. Okay, if it's inside the bracket, and again, this is where I normally talk about the x, it's going to go that way around. So it's going to reflect in the y-axis. All right, so it's going to go that way around. So let's have a look at some examples. So I've got minus x. So we're looking at basically x squared. So this is minus x squared. All right, so this is on the outside. So this can reflect in the x-axis for the top one. This is minus x in a bracket inside squared, so this is going to be a reflection in the y-axis. Let's have a look at this one. A little bit more kind of involved, so there's kind of a few things going on here now. So describe the translation. So what we've got is, you've got the 2x, so that's I'm now looking at combining them here. So you've got the 2x inside, which is a stretch by a scale factor of a half in the x direction. And then you've got minus within the outside reflected in the x-axis. All right, so you'll see both of these kind of written down. So stretch in the x direction, scale factor of a half, so that's the bit inside, and then reflected in the x-axis, all right, which is the top one there. Okay, so over here, so let's have a consider first of all. So you've got minus x, so that's a reflection in the y-axis, that one, and then you are timesing it by 3, so it reflects in the, I'll say it again, so reflection in the y-axis, and then stretch in the y direction by a scale factor of 3. So stretch in the y direction, scale factor of 3, and a reflection in the y-axis. All right, so two things kind of going on. So you'll start to see that happen more and more and more, not just one thing taking place, maybe one or the other. All right, so that is going to take a bit of practice. So please go to maths-school.co.uk. Do look at some of the questions based on those. All right, it is a very, very relatively new GCSE topic, but it does appear in certainly an awful lot of kind of A-level kind of questions. All right, so that's it for me. Right, well, thanks for listening, and of course, please feel free to revisit this lesson and obviously take further notes on it if need be. All right, thanks, Ian.